Today we're going to look at an integration technique of partial fractions. Well, what we'll be doing is taking a rational expression and breaking it into individual fractions with simpler denominators to make the problem a lot less complex. And the technique is we would factor the denominator and then we would write as a sum of terms using those factors. The form of those terms would be ax plus b, and we would write constant over ax plus b. Or sometimes we'll get repeated ax plus b to the n, repeated factors. And so that would be a constant over ax plus b plus all the way out to the final constant over ax plus b to the n, reaching all the powers in between. So if this was a 9, I'd have 9 total factors. And sometimes we'll have an x squared plus a, and that would be rewritten as a constant times x plus another constant over x squared plus a. So we're going to then rewrite this as a single fraction, and we're going to compare those constants with the coefficients in the original fraction, in the numerator. And we're going to make those constants, consider them variables, and we will be solving a system of as many of those variables as we have, n variables, n unknowns, it will give us n equations. And so we will be solving a system of linear equations. How you solve that system, I really don't care. I recommend that you do something simple in most of these problems where there's 2 equations, 2 unknowns. But if it gets to be 6 or 7 equations and 6 or 7 unknowns, I would resort to the Gauss-Jordan technique or something a little bit more, less work, shall we say. The calculator can actually handle that. Okay, example, find the integral 2x plus 1 over x squared plus 3x plus 2 dx. So what we would do is factor the denominator. And so that would be x plus 2 over x plus 1. I have 2 factors here. So I'm going to have constant over x plus 2 plus a constant over x plus 1. When I put this back together, I get a times x plus 1, or ax plus a, and b times x plus 2, or bx plus 2b. And I'm going to have to set the x terms in the original back here, 2x, with x plus b. And so a plus b equals 2, and 1 is going to be a plus 2b, so I got a plus 2b equals 1. And so now I will solve, plugging in the values for a and b, I will solve the, well, a is 3 and b is -1, the simpler equation. So I got 3 times integral 1 over 2x plus 2 dx minus 1 times integral of 1 over x plus 1 dx, which is 3 times the natural log of x plus 2 minus the natural log of x plus 1 plus c. So it's not that hard once we break it down. Sometimes it's not going to break down quite the same. So here I have an integral of 3x plus 4 over 9x squared plus 6x plus 1 dx. If I factor the denominator, I get 3x plus 1 squared, so I get a repeated factor. And so I'm going to need a over 3x plus 1 plus b over 3x plus 1 squared. I don't have to go past 2 here. So if I equate the like terms, I'm going to eventually find that a equals 1 and b equals 3. So I'm going to have the integral of 1 over 3x plus 1 plus the integral of 3 over 3x plus 1 squared. Well, in this case, I would let u be 3x plus 1. du is 3 dx. I don't have the 3 in the numerator, so I will multiply by 3 over 3, and I'm left with the denominator. The one in the numerator gets absorbed in the du, and so I get 1/3, and this will become a u. So 1 over u is the log of the natural of the absolute value of 3x plus 1 in this case. That's what the u would have been. Here u is going to be 3x plus 1, du is 3x, and that I can see a little bit easier. And so this I'm going to make 1 over u squared du. The 3 is already here, so we don't have to worry about that. So I get my first term plus the integral of 1 over u squared du, which is just going to be negative 1 over u. And so I get 1/3 the log of absolute value of 3x plus 1 minus 1 over 3x plus 1 plus c. In our last example, we're going to find the integral of x squared plus 2x plus 6 over x cubed plus 5x. And so we're going to have the factor of the denominator as x times x squared plus 5. So we're going to look at this expression factored with the denominator factored. And we're going to have an x squared term. And so it's going to be ax plus b over this term plus c over x. And so if I go through this, equating the like powers, I'm going to get a equals 1, b equals 2, and c equals 1. So using my constants, I'm going to have the integral of x plus 2 over x squared plus 5 dx plus the integral of 1 over x dx. I'm going to break this first integral down, and I'm going to have the integral of x over x squared plus 5 plus 2 over x squared plus 5 plus the integral of 1 over x. Now here I'm going to let x equal u equal x squared and du equals 2x dx. And so I'm going to have the integral of x over x squared plus 5 is the 1/2 the integral of du over u, or 1/2 the natural log of x squared plus 1. I don't need the absolute values here because there's no way x squared plus 1 can be 0 or negative. So I have the 2 over x squared plus 5 plus 1 over x. I have to deal with this 2 over x squared plus 5, and that is 2 times the arctangent of x over the square root of 5, which rationalizes as the square root of 5 over 5. And then also 1 over the square root of 5 here, which rationalizes the square root of 5 over 5. This 2 is coming from the 2 in the numerator. And then I have the natural log of the absolute value of x plus c. So these are all different, and we have to always be aware that we have to make adjustments as we go, such as breaking this into 2 integrals, the x plus 2 over x squared plus 5. In any event, it's not that difficult, and all we have to do is work it step by step by step. Well, thank you for watching, and I hope that you would consider hitting the subscribe button before you leave. And we do have other videos, and there will be one with practice problems for this coming soon. The practice problem videos, I give worked out solutions, so people aren't left in the dark as to how to get there. Thank you again.